Well, good day, subscribers. I'm super excited about today's episode because today is part 3 in the 7-part series, How to Build a Robinhood Auto Stock Trader in Python. In today's episode, we're going to work on what I think is the most important part of the entire system, the trading strategy. So let's jump in. Alright, so before we get working on the trading strategy for today's part, let's do a quick review of what we completed in the last part, part 2, and an overview of what we want to complete in this part, part 3. In part 2, we started working on the trader that interfaces between our Python code and the Robinhood platform. We looked at Robin Stocks, the API that we're going to use to connect between our Python code and the Robinhood platform, and built a script to log into Robinhood and give us the current price of a list of stocks we built. In today's part, we're going to build a simple trading strategy. This strategy will take the current price from part 2 and return a buy, sell, or hold command. The strategy that we're going to use is going to be a simple price over SMA strategy. For anyone new to stock trading, SMA stands for Simple Moving Average, meaning it's the average of a moving block in time. In this case, we're going to use the simple moving average of the past hour. Our strategy will place a buy command if the current price over SMA is less than 1, and a sell command if the current price over SMA is greater than 1. Now, this strategy on its own will most likely not make you rich, but the good news is you can implement any type of trading strategy here and easily integrate it into the system we're building. So, now that we have a good understanding of what we're building in this part, let's fire up our favorite IDEs and jump right in. Alright, so here we are back on the desktop. As you guys can see, I have one new file here open called trade_strat.py, and this is where we're going to build our trading strategy. So this trading strategy we're going to build in the object-oriented programming format. So we're going to make a class, and then we're going to give that class different attributes. I did it that way partly just because I wanted to better teach myself how to program in object-oriented, but in addition, I just thought it would be a better way to do this class. So let's jump right in. And the first thing we're going to need to do is get our imports in. So here we're going to be importing import pandas as PD. So pandas is a data frame manipulating API. It's super useful, so if you guys have any interest in data science or really any data manipulation, pandas is a good one to know. And then we're going to import robin_stocks.helper as helper and robin_stocks.urls as URLs. Okay, now let's go over here and we're going to start making the class. So we're going to call it class trader. That's going to be our class name. Alright, and every class has an init function, which stands for initial for anybody who's new to this. So what that means is when we run this program, the first thing that's going to run is going to be this init class. So when we call the class, it's going to set these initial values for the class. So what do we want our inits to be? We want self.stocks is equal to stocks, which is an attribute we're going to send in. And for anybody, like I said, who's new to object-oriented programming, self is just a way you call into its own class when you're in the class. So when we want to reference self.stocks, we'll just call self.stocks and it'll know that we're in this place right here. Alright, and then I'm going to just pull these other ones over from my copied version. And so here we're going to have self.SMA_hour, which is the SMA that we're building that we talked about. And that's going to be a dictionary. And then we're going to have runtime is equal to 0. This will be useful later when we get the historical data. What it's going to do is we're going to update every 5 minutes because that's when the historical data gets updated on the Robinhood website. Self.buffer, I'm gonna comment this out for now, what that will be used for, and you can choose to use it if you want or not. But what that buffer is used for is in your SMA, instead of just having it if it's greater than 1 or less than 1, you can have it if it's greater than 1 with a buffer or less than 1 with a buffer. It'll just give you a little bit more control over that. And then finally, self.price over SMA per hour. So we have the SMA per hour, and now this is the price to SMA ratio that we're going to be making our trades actually over. Alright, so now we've got our init set up. Let's save that, and let's go back to our trader.py file. Now what we're going to do here is we're going to initialize the new class in our trader.py file so that we can call the trader.py file and it'll reach into the class created in the trade_strat. Okay, so we're going to import it up here at the top under config. So we have import trade_strat. And then down here, after we get our stocks, after we do stocks equals get stocks, we're going to do ts equals tradestrat dot trader, and then we're going to pass stocks, which is one of those things that we had to pass for the init attribute. Alright, so now we've initialized it right here. So all of our initial attributes are set. And just to show that, let's add a print function here. So we'll do print, let's say, price over SMA over hour. And this is just going to print out a dictionary of zeros because we haven't set it to anything else yet. But just to show you that it is working, we're going to do that. And then let's call the trader. And you can see right here we have price, SMA hour, and it gives us a 0 for each one of the stocks, just like we wanted. So great. Now we've got everything initialized. Let's build our first attribute that is going to be called. And this is the most important attribute in this entire class, in my opinion, and it is the historical data attribute. So historical data is the data from the Robinhood platform that you're pulling in to kind of get to build that SMA. And so it's going to have basically the stock prices for the previous time periods for whatever time period you specify. So this is probably going to be the most complicated part, so I'll go slow, but if you guys have any questions, just put them in the comments and I'll try to answer them as quickly as possible. Alright, so we're going to call def get historical prices, and we're going to have self, stock, and span. Okay, and just as a reminder, this is taken from the Robin Stocks API and added month and 3 month. Okay, so the first thing we want to do is do what is the span. So here we have span interval, we have day, 5 minutes, week, 10 minutes, month, hour, and so on. So what this means is if you're calling the span for the day, meaning today, then it'll give you prices for every 5 minutes. That's how the Robinhood platform holds its prices. If you want to do it for a week, it's going to give you prices for every 10 minutes. If you want to do it for a month, it's going to give you prices for every hour. So it just depends on how accurately you want those prices. Obviously, if you are doing a larger SMA, you're going to want a larger time period. So you're going to have more distributed data, and there's nothing wrong with that. It'll still build the SMA the same way. But since we're just doing an SMA for an hour, we're going to use a day. But just to show you all of the options, you have day, 5 minutes, week, 10 minutes, month, hour, 3 month, hour, year, day, or 5 years, week. Meaning if you wanted to get the prices for the past 5 years of a stock, you would be given those prices for each week. But like I said, we're going to use day. So that'll be something we'll pass right here. We'll pass day for the span. Okay, and then we just do interval equals span, interval, and then we're just getting the span, so whatever we pass in. Okay, so now we're going to use those libraries that we brought in, and we're going to get the symbol. So that's the symbol for each stock. So we have the stock, we get symbols equals helper.input to set stock. So this is how we're setting it. And then URLs equals URLs.historicals. And then payload, we're doing the symbols, and we're joining in that symbol. Interval, and that's going to be that interval that we set up here. Span, this is that span that we set up here. And then bounds is just regular. And then finally we have data equals helper.request get URLs result payload. And so what this is going to do is this is going to pull the data set that we're going to use to create our SMA. So let's start manipulating that data set. Why don't we take a look at what that data set's going to look like. So we'll have print data okay, and then over here we're going to call data equals ts.historical, get historical prices, and then we are passing stock and span equals day. Alright, let's run that. So as you can see, it comes in as these big chunks, but this is basically 5 minutes span, and then it gives the prices for each one of those sections. So now let's clean up that data a little bit. We're going to create a list called historical data, and then we're going to do for item in data, for sub item in items, historical, and then we're going to append it to that list. So this is just going to help us clean up this formatting, and just to show you what that looks like, let's take a look. So here what we've done is moved it into a list format just so we can manipulate it a little bit better. And now we're going to turn it into a Pandas data frame. So what we're going to do is we're going to do df equals pd.dataframe historical data. And let's take a look at what that looks like. It'll be in a little bit cleaner format. So here we can kind of see things a little bit easier. So now we have it set up in a Pandas data frame, and this is why Pandas is so powerful. So we can see here that Pandas takes that craziness that we were looking at before and moves it into this format where we have these nice columns that we can look at. And so here we have the close price, the highest price, the interpolated, so just all of these different things. And it's much easier to deal with. So now that we have that, let's start manipulating the data within the data frame. Alright, so we have dates times equals pd.toDateTime df.lock, and then we give the column. So what we're going to do is we're going to take this column here and change it into a DateTime attribute, and that's just going to help us later when we need to call it. And then we're just going to lock out the close prices because that's really what we want, and we're going to convert them to floats. Okay, and then finally we are going to build the data frame that we're actually going to use, and that's going to be called df prices. So df prices is going to be made up of those closing prices and the date times, and then we're going to just rename the column to close prices for the stock, so it's just going to give us the stock, and then set index to begins at. So rather than explain what each one of these things does, I think it would just be easier if I show you the difference. So I'm going to run it. Alright, so let's take a look. So before, what we had is we had this data frame that had 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. And what we've done is converted it into a data frame that has 2 columns, where the first column is the date or the time, and the second column is the stock and its closing prices. And that's kind of what we're going to want for this. And these prices is what we'll use to build the SMA. Alright, and then lastly, we are just going to return DF prices. And that's going to be the end of our getting historical data definition. So let's just do a quick review of that, because it is kind of the most complicated function in this little part. So we have get historical prices, and we're passing in these attributes. Then we have the span. We have to set the span, which we're going to set up here, and we're going to get the interval. We're going to call the API that we're bringing in from that library, and we're going to get the data. We're then going to manipulate the data into a format that we feel more comfortable with, that looks like this, so we can see it a little bit easier. Then we're going to lock out those 2 columns, put them together in a new data frame, and then set the index of our data frame to be the dates. And then we're going to return that data frame. And that's going to wrap up our getting the historical data. Now, just a little note, if you wanted to do an SMA for a longer time period, let's say you wanted to do the SMA for the past year or an SMA for the past month, you could just change right here what the span is and what the interval, that would change what the interval is, and you could do week for 10 minutes or month for hour. And like I said, I understand that this part is probably the most complicated, so if you have any questions, just put them in the comments and I'll try to get to them as soon as I can. Alright, so now we have built our historical data and we've got our init running. And so we've got 3 more definitions that we have to build in this class, and then we'll be done for the video. So a little bit longer video today, but this is kind of the most important part of, I would say, the entire system. So this next part is going to be creating the SMA. So remember, up here we had self.SMA hour, and then we just made a dictionary all set to 0 for each stock. And so here what we're going to do is we're going to do def get SMA. We're going to pass stocks df prices, which is this return from the historical prices, and then the window. What the window is what section of price, how far back are we going to look? And so this is why I say it's an SMA for the past hour. Because each price is 5 minutes, and 12 times 5 is 60, and 60 minutes is 1 hour. So we're looking back at the past 12 prices. If you wanted to look back for, let's say, 2 hours, you would say the last 24 prices. If you wanted to look for 3 hours, it would be the last 36. And if you change the span, you're going to have to relook at this window. So they all kind of work together, but for this case, we're looking at the SMA for the past hour, so we're doing the past 12 prices. So we have SMA equals df underscore prices, so that's our data frame that we're looking at right here, is rolling window, min period window, and then we're going to get the mean. So we're going to get the average for the past 12 prices, and it's going to be a moving average every time it updates. So we're just getting the last section, which means every 5 minutes when the price updates, the SMA is going to update as well. Then we're going to round that number and set it to a float. We're going to give it to 4 integers, and then we're going to return that SMA. So pretty simple, but why don't we just take a look at what that outputs. So over here in our trader.py file, we're going to get rid of that, and we're going to do SMA equals ts.get SMA, and then what do we have to send it? We're going to send it the stock, df prices. So df prices, and then window equals 12. And then let's print out the SMA. Okay, so here what we have is for INPX, the average price for the past hour is $1.38 and so you can see it's up above that price. So right now we wouldn't want to buy it because it's above the average price that it's been for the past hour. For HHT, it is 87 cents, and right now it's at 85, so it's a little bit below. That would be a buy. We want to buy that. And then for CNET, it is the SMA is $1.47 about, and it is currently at $1.48. So it's just a little bit above that SMA. Okay, so now back in our trade_strat.py, we are going to now get the price over SMA. So again, just kind of a simple definition. All it is def get price over SMA. We give it the price, we give it the SMA, we divide the two, and we round it to 4 digits. And let's just take a look at what that is going to do. So back here in our trader.py, we are going to do P SMA equals TS dot get price over SMA, and what do we have to feed it? Price and SMA. They're going to give it the price, we're going to give it the SMA, and then we are going to print out the price over SMA. So this is going to be that ratio that we talked about earlier in the video. If it's above 1 or below 1, that's going to trigger our buy or sell commands. So here we can see the price to SMA for our first stock is just above 1. For our second stock, it's just below 1. And for our third stock, again, it's just above 1. So that goes back to what we were saying before. This would be a sell, this would be a buy, and then this would be probably a hold, but it is above 1, so it would be a sell. Okay, so let's move back into our trade strat file, and we're going to do the last definition for this video. So this video is going a little bit long, but that's okay because it's very important. And so this one is going to be def trade option, and we're going to give it self and price. So this is what's going to output our buy, sell, or hold command. So the first thing we need to do is get our new historical prices every time it updates. And for us, that's going to be get new historical prices every 5 minutes. So here we do if self.run is divisible by 300 divided by 60. So this is really, really what you could do is put here 5. But I like to leave it as 300 divided by 60 because then I can just update this whenever I need to change it. But you know what? Let's just leave it 5 because it's simpler. So if it's divisible by 5, and that gives an attribute of 0, meaning every 5 minutes, we're going to get new historical prices. We're going to update that historical prices. We're going to get a new column, and then we're going to set that new section as the last 12. So what this is going to do is, in that data frame that we were looking at before, every 5 minutes a new price is going to be added to the bottom, and this is going to shift that window down, collect that new price, and update the SMA. So as the stock goes up, the SMA is going to shift up too, or as the stock goes down, the SMA is going to shift down. Alright, and then we're going to, now we have that SMA, so what do we have to do? We have to calculate the ratio. So we're doing self price over SMA for that stock is get price over SMA, and that's just for that stock. And then we're going to set the P over SMA to self price.SMA. So now we have this variable that is the same. Alright, and then here is the last section. This is going to actually give us our commands. So now we have I1. So that's I1 stands for indicator 1. So if you wanted to add more indicators, if you wanted to add more than just the price over the SMA, you could have I1 and I2 and I3 and so on. But what we're going to do is I1 is a buy command if price over SMA is, for that stock, is less than 1, and I'm going to remove this buffer part because we're not using it right now. Okay, else it's a sell if price over SMA for that stock is greater than 1. And again, just remember that buffer is if you wanted to make it more than just 1 or not 1. Let's say you wanted to say if the ratio is above 1.01, you could make that change in the buffer. And that way you can very easily update it. Otherwise it's going to be set to none. So the reason I have this section right here, this if, elif, and else, instead of just letting it be up here, is if you wanted to add more than one indicator, you could then put the logic in here to say, let's say if 2 of those indicators say buy, then it's a buy, even if the other one says sell. And so it just gives you a little bit more manipulation control here. You're free to remove it if you only want to use one indicator, but I do suggest leaving it. I felt it really made it easier for me to read the code when I would add another indicator. So if you wanted to add, let's say, an indicator that was showing momentum in the stock, so how fast is the stock growing or how fast is the stock falling, then you could say something like, if momentum is slowing down, meaning it is growing but it is slowing the rate at which it's growing, or it is falling and slowing the rate at which it's falling, you could combine that with your other indicator and put them together to make a more robust trading strategy. Okay, so now we have our trade. So our trade is either going to be a buy, a sell, or a hold. And then the last thing we have to do, all we have to do is return our trade. All right, and let's take a look at what that's going to look like. So now we have all of that built. Let's get rid of that. And we're going to get our trade. Okay, so I'm going to actually leave this here so we know that the price over SMA for INPX is a little bit high, for HHT it's low, and for CNET it's high again. So I'm going to guess it's going to be buy, sell, buy. Sell, buy, sell, but I don't know if the prices have changed, so let's take a look. Alright, and I was correct. It is still the same. So it is for INPX, we're getting a sell. For HHT, we're getting a buy. And for CNET, we're getting a sell, which is what we expected. So that's great. So now we have our commands. In the next video, we're going to fully integrate the trading strategy into our program here that connects to Robinhood. And we're going to actually give it the ability to buy or sell on your actual Robinhood account. And so that'll be really, really cool. Let's do one final review of what we've done in the trading strategy and what we've done in the trader, and then we'll wrap up this video. Okay, so this trading strategy is going to be built in the object-oriented programming format. So we're going to import Pandas, Robinstock's helper, and Robinstock's URL. The first thing we need to do is initialize our class trader. And we do that with stocks, SMA hour, runtime, and SMA price over SMA. Then we got to get the historical data. So this is the data from the past interval that we're going to use to build our SMA. We need a span, which creates our interval. We get our symbols, and we get the historical data, which comes in a very hard to read format. We manipulate that data to become a Pandas data frame, which is much easier for us to read. We take the dates and the times along with the closing prices and create a special data frame that only has those closing prices that we can use with that sliding window, and that's going to be called df_price. Then we get the SMA by using that df_price that we built and using a sliding window. In our case, it's going to be the past 12 times because each time is 5 minutes. And that's going to give us an hour. Then we do price to SMA, so we just build that ratio. It's a very simple formula, just price divided by SMA. And then lastly, we have our trading options. And so like I said, here we have this if runtime is divisible by 5, so that's what this means, is divisible with a remainder of 0, meaning it's directly divisible by 5. This is going to update our historical data every 5 minutes, which is what we need because that's how quickly Robinhood updates the historical data. So this is going to give us a new sliding window, so a new SMA every 5 minutes. The price is going to, then we have to get the new price over SMA for every 5 minutes when it gets updated, and that's going to be set right here. And then lastly, we just have our if indicator 1 is a buy command, or I'm sorry, indicator 1 is a buy command. If the price over SMA is less than 1, it's a sell command if it's greater, and it's a hold or it's a none if it's neither of those. And here is where we could add our buffer. So if we wanted to make the buffer something like I have 5%, so if we wanted to say it's 5%, then we could add that in right here. So we could do, if it's less than that, minus the self dot buffer. Let me double check that, make sure that's right. Yep. Or we could do here plus. That's going to give us a little more cushion, so we won't buy or sell the stock until it really goes below, not just as soon as it goes below, but we're going to give it a little bit of wiggle room so it has some way to come up before we sell it. So if we ran that now, they're all kind of close, so these would actually all be holds, so we wouldn't do anything at this time. And I'll show you guys, I'll show you guys that right now. Let's save this. Let's take a look. And you can see, oh, okay, so for this one it's actually a sell. So the we have 0.03, and here we have, 0.005, okay. So we have 0.005 is 0.5%, and so we are way above that 0.005, so that's going to be a sell, a hold. This is going to be a hold and a sell. Okay, and then lastly, we just have this simple logic that'll help you integrate if you want to use more than one indicator. So it'll give you a buy, a sell, or a hold command, and then it returns that trade. And finally, within our trader.py file, we have to initialize and set this new file, this new trade strat file. So the first thing we do is we import it. We import trade underscore strat. Then we initialize it over here. TS equals trade underscore strat dot trader for the stocks. That's going to set those initial values. And then here we do trade equals TS dot trade option stock and price, and then we print out the trade. All right, so let's just see if it's changed. So it's still sell, hold, sell. So it'll update every 5 minutes. And that'll give us a new SMA, but as the price changes, even with that 5-minute SMA, it might go below or above. So as we run this throughout the day, it'll give us different commands, and in the next video, we'll set up the trader to actually send buy or sell commands to your Robinhood account. So I hope you guys enjoyed this video. I know this video had a lot of information on it, so if you have any questions, please put them in the comments below. I'll try to answer them as quickly as possible. If you guys like this video, please leave a like. Otherwise, thanks and subscribe.